covering climate, weather, and the industrial enterprise from Penn State Meteorology. Here is Up in the Air.
Hello and welcome to the first episode of Up in the Air for the spring semester. I'm Ryan Gold. We've lost Logan and Mike, but we have a new member, Joe Speir. Joe, would you like to introduce yourself?
Well, of course. Well, I'm a junior here at Penn State and I'm studying meteorology, and I'm really excited to join the team here at Up in the Air. We've got a couple good stories here for you tonight, including one on meteorites falling down in Cuba and a cavity that opened up in an Antarctica glacier.
We also have a package that I did about how the Arctic ice is melting faster than Antarctica. But first, here's Update in the Air. In a town in western Cuba, residents were impacted by a meteorite strike on Sunday, February 1st, which blew out some of the windows near the crater. The town in question, Viñales, Cuba, which has a population of around 27,000 people, suffered no injuries from the meteorite strike. The meteorite was seen just moments before hitting the ground as a meteor on various satellites and radar. One such satellite was the GOES East geostationary lightning mapper, which was seen as a quick flash over western Cuba. A team of scientists would travel to Pinar del Rio province so they can collect fragments of the meteorite.
Within past decades, volcanic eruptions in the extratropics have been launching sulfur into the lower stratosphere approximately 10 kilometers above the surface. The extratropics are a range of latitude beyond the tropics, which are latitudes north and south of the equator. The impacts on climate from these eruptions have been relatively small, adhering to a general idea that extratropical eruptions are weaker than eruptions in the tropics. However, researchers at the Geomar Helmholtz Center for Ocean Research, Kiel, and other institutions contradict this rule. Volcanoes cool the surface when vast amounts of sulfur gases are sent into the stratosphere and create aerosols that block solar radiation. Eruptions in the tropics were assumed to have a greater cooling effect because aerosols would need to travel a farther distance to reach the poles. Researchers then modeled the explosive 1991 eruption of tropical volcano Mount Pinatubo across varying latitudes. They found the aerosol lifetime was relatively similar and more concentrated in the hemisphere instead of globally. The results from this study showcase that aerosol lifetime and therefore surface cooling heavily rely on how far into the stratosphere volcanic sulfur can ascend. Researchers now hope to have a better understanding of how past climate change was impacted by volcanic eruptions.
Despite the severe cold from the polar vortex during the last week of January, the first month of this year was overall warmer than average for most of the lower 48. This can be seen in this map, showing the departures from normal for January provided by the Climate Prediction Center and NOAA. While the northern plains, Midwest, and eastern Great Lakes ended a little colder than average for January, the rest of the nation was several degrees above average. The coldest air, which we saw last week, was focused in the northern plains and upper Midwest, where average temperatures throughout the month were in the single digits. For example, Fargo, North Dakota saw an average temperature of 6.3 degrees in January, which is 3 degrees below their average. Just to see how different the temperatures are, here is the map for the average temperatures for January, also provided by the Climate Prediction Center and NOAA. Nearly everywhere else remained warmer than average. For example, Glasgow, Montana, which is just west of some of the coldest temperatures, reported an average temperature of 22.2 degrees, which is 8.4 degrees warmer than their average.
A study on the impacts of climate change on coral reefs has found that corals that prefer to live alone and outside of reefs may survive the effects of climate change. With an international database of fossils, a team from the University of Texas at Austin was able to study coral species from 56 million years ago. At this time, the planet was undergoing a 200,000-year transition period between the late Paleocene and early Eocene epochs, where temperatures and atmospheric carbon dioxide levels were drastically increasing. Compared to today, temperatures were 14 degrees Fahrenheit hotter and oceans were more acidic. Researchers were able to find that solitary coral species flourished during this time, and they were able also to pinpoint specific traits that help corals to survive. Among these traits was an ability to find food independently. Some corals get their food from heat-sensitive algae that live in the coral, but in rising sea temperatures, these algae leave and cause coral bleaching. While corals might survive climate change, they could create issues in their ecosystem if they aren't building reefs. Compared to corals and communities, the solitary species won't showcase the colorful qualities of reefs. Scientists hope to use these past traits as a way to help today's corals and reefs adapt to climate change in a best-case scenario. However, with the rapid rate of warming that we experience today, researchers hope to find a solution soon.
For almost 7 years, NASA's Mars rover Curiosity roamed the red planet, but most recently, scientists discovered how to use its instruments to accomplish something new. By repurposing data, which tracked movement and orientation, researchers were able to measure the surface gravity of the planet. The gravity information might help explain how Mount Sharp, a mountain 3 miles above the Gale crater, where Curiosity landed on August 6, 2012, was formed. Early speculation was that the Gale crater was once a lake that was filled with sedimentary rock, and the layers of sediment were eroded by the wind forming the mountain. Sediments tend to become compacted over time as layers build above them, which increases their density. However, the rock under Mount Sharp is low in density. This would suggest that the sediment was never buried very deeply. The data could indicate that the bottom of Mount Sharp may consist of carved-out lake sediment, and the top was built by wind-blown particles.
Researchers were surprised to find a massive cavity under the Thwaites Glacier in West Antarctica. The hole could cover 2/3 of Manhattan, is about 1,000 feet tall, and contained almost 14 billion tons of ice that has melted in the last 3 years. NASA's Operation Icebridge found the cavity using ice-penetrating radar, along with data from Italian and German radars. Cavities cause glaciers to melt faster as more water and more heat are exposed to the glacier bottom. The ice in the Thwaites Glacier could raise the ocean's level by 2 feet, and the nearby glaciers could add 3 feet to that as well. The International Thwaites Glacier Collaboration will begin experimenting in the summer of 2019 to learn more about the isolated area. Scientists monitor the grounding line, where the glacier and land meet, to see how far off the continent edge a glacier floats. On the western edge of the Thwaites Glacier, the grounding line has been moving inland at a rate of 0.4 miles a year since 1992. However, the side of the glacier is experiencing a very high melt rate. The eastern edge of the glacier has gone from a grounding line retreat rate of 0.4 miles from 1992 to 2011 to 0.8 miles a year from 2011 to 2017. While the grounding line rate has doubled in speed, the melting of the eastern side is less than that of the western side. Researchers in the International Thwaites Glacier Collaboration hope to use this data to better understand complex interactions between the ice and the ocean and how this will impact sea level rise in the future.
We now go to a package that I did about how the Arctic ice is melting faster than Antarctica.
We all know that the ice caps are important. They contain 3/4 of Earth's fresh water, they are home to many species of animals, and they reflect sunlight back into space, cooling the Earth. But these ice caps are melting, but one pole is melting faster than another.
The Arctic is not only melting faster than expected, it's melting faster than Antarctica. Air temperatures are climbing due to global warming, and so are water temperatures, which makes the ice melt faster. The period of winter where the water is actually cold enough to freeze is getting shorter, which means ice floes are getting smaller. The Arctic could be ice-free in late 2030, but there is hope with Antarctica, where the melting is 1/3 of what was projected in the past. There are many different factors which could result in the Antarctic melting slower than the Arctic. Antarctica's topography is not ideal for moisture flux to bring in warm moisture intrusions, which are important for surface warming. Moisture intrusions create clouds which release infrared radiation downward toward the surface. These are more common in the Arctic rather than Antarctica, since the Arctic is an ocean which consists mostly of sea ice, rather than the Antarctic, which consists mostly of elevated ice-covered land. Another possible factor for why the Arctic is melting faster than the Antarctic is the flow of the ocean surrounding it. Antarctica is surrounded by the Southern Ocean, which has a west to east flow. There tends to be a surplus of upwelling in the Southern Ocean as well, which brings the colder water from below the surface to the surface, which is then circulated west to east around Antarctica. Because of this cycle and the circulation around Antarctica, there is a lack of heat that is brought into this circulation, unlike in the Arctic, where the warmer water is circulated in from the North Atlantic.
We are losing the Arctic fast, and while we aren't losing Antarctica as quickly, we still have to worry about losing both ice caps completely. Without them, the Earth will warm even faster, we will lose hundreds of species of animals, and the sea levels will rise to dangerous levels. From up in the air, I'm Ryan Gold.
Hello and welcome back. So Joe, we had that Arctic blast last week which just decimated us with cold weather, and we even got school canceled.
Yeah, on that Thursday that we didn't have school, we did reach into the negative temperatures, so it was good to not have to go outside. But as we got into the weekend, it did start to warm up a little bit.
Yeah, I actually was able to get out of my apartment and actually do some errands that I needed to do. But now we go to Casey at the climate wall. Casey, can we expect more warm weather?
You know what, Ryan? We should be above normal next week. I'll touch a bit more on that in our temperature outlook. Almanac data for today, though, average high of 36 degrees with a low of 21. Record high of 57 set back in 1925. And honestly, we're not too far from that today. We are quite a bit of ways from -6 set back in 1977. Now I can explain this temperature outlook, which is for February 12th through the 18th. Look at all this blue across the majority of the state. Those darker shades of blue indicate a higher probability of those below normal temperatures. So as we look into central and southeastern Washington, as well as the northern bit of Oregon, they're expected to be below normal next week. Down in the southeast, especially in Florida, in the southernmost tip of Georgia, have the greatest probability of being above normal. Here in State College, though, we should be about average. We have a more zonal flow next week, which indicates a west to easterly flow, which usually is associated with normal and average temperatures. Precipitation outlook, once again, for February 12th through the 18th. 47 of the 58 continental states should be above normal precipitation next week. As we look into the southwest, Southern California, the southernmost tip of Nevada, as well as Arizona, have about a 90% chance of being above normal precipitation-wise next week. The Great Lakes states, as well as the southern central plains, should be above normal as well. Down in Florida, from about Daytona Beach all the way down to the Keys, they should be below normal for precipitation. And up here in State College, we should be above normal as well. The drought monitor, we're still focused out in the southwest, those four corner regions. This has shifted to the east a little bit, now more in Colorado and New Mexico. Last semester, it was focused right around the four corner region, but this is new up in Oregon. We have a great bit of drought there. What's interesting is down in Florida, once again from the Keys up into Daytona Beach, of course, no drought to worry up here in Center County. The snow depth map, though, I decided to include Canada because I just thought that was great. They have an abundance of snow to our friends up in the north. We have a great bit of snow along the Sierra Nevada mountains, as well as up in the Rocky Mountain states, including the northern central plains as well. And what's interesting is, in the Midwest, I'm from Chicago, and my mom was sending me pictures of outside. We had several inches, if not a foot of snow that has already melted. We had a front move through that brought in some rain and warmer temperatures melting the snow out there, but we are still left with a good bit of snow here in Pennsylvania and as well as in the Northeast. The weekend is looking normal. Temperatures for this time of year are about in the mid-30s, so on Saturday it should be beautiful, mostly sunny, about 30 degrees as our high. As we head into Sunday, we do have those increasing clouds throughout the day, and we do have a chance for rain overnight. So Ryan and Joe, if you do have those weekend plans, I would recommend getting them done on Saturday, if not by early evening on Sunday.
All right, thanks, Casey. We'll be sure to do that. And I got to make sure I got to get my grocery run in, my trip to the gym in on Sunday morning.
Oh yes, so do I. Thank you for joining us. We'll see you next week up in the air.